Okay, so last time we discussed two major topics. Yes, that is, we introduced normal distribution, whereby we discussed or we defined what a normal distribution is. Then after that, we also gave some examples of that is of situations or maybe things which we usually use normal distribution. Okay, like real life examples of where we apply normal distribution. We also discussed about that is properties of normal distribution, which they are very key. Okay, you might come across those um, uh, properties maybe in your exam, and not only in your exam but also maybe in in your area of work. Okay, maybe the current or the future, more so if you are dealing with what you are dealing with the data. We also discussed about the central limit theorem, and we saw what central limit theorem or CLT means, and also we defined or we stated that is the theorem. Okay. Yes, we also I don't think if we introduced binomial distribution, but today I want us to that is do binomial distribution. Okay, I'll start on binomial distribution. Then after that, we'll also that is combined binomial distribution with Bernoulli distribution. Okay, because they are almost the same. Okay, what varies between the two distribution is the size. Okay, the sample size of your trials. That's what changes. Like for binomial distribution, we have more than that is more than one sample, or more than one trials. Okay, while in the other hand, when we are discussing about Bernoulli, it's we I said it's a special type of binomial, but in this case n is equals to 1. Like Bernoulli, it's like a distribution of one trial. Okay, of one trial, which is binomially distributed. So I want us now to discuss in depth about that is binomial distribution. What is binomial distribution? Some of the examples of binomial distribution. We'll also discuss about properties of binomial distribution. Okay, and also we shall understand in depth that is a binomial distribution. Okay, then with that we'll go to analyzing binomial distribution, and then we will be good to go. Okay, then maybe from tomorrow, that is tomorrow I want us to finish about the theory part of that is distributions. So tomorrow we shall discuss about Poisson distribution. Okay, and then the day after that we'll do the practicals for distributions, and then we'll also do what we call hypothesis testing as our last topic, and then we'll call it that is a class or a unit. Good. Now let me start with the definition of binomial distribution. So the binomial distribution, of course, deals with the likelihood. Okay, it deals with the likelihood that one of the two possible outcomes will happen. Okay, and maybe if it is an experiment, okay, that is the outcome of the first experiment or the outcome of the first trial, it is independent or mutually exclusive, meaning it won't affect the outcome of the what, of the second output. Okay, but don't worry, we shall go in depth about that is those kind of that is those properties. So let's start with binomial. So binomial distribution, of course, it's a probability distribution. Okay, that summarizes the likelihood that a value, okay, will take one of two independent values under a given set of parameters. Let's assume maybe we are tossing what? We are tossing a coin. Once we toss a coin once, we know of two possible outcomes. Either we'll get a head or a tail. Okay. So binomial distribution now gives us the likelihood that an experiment or a trial, okay, will give us one of what? One of these two independent what? These two independent that is values, okay, or outcomes, okay, but under a given set of parameters or assumptions, okay, under a given set of assumptions. Which are these assumptions? Which are these underlying assumptions? Okay, now let's go to the second part, which is the underlying assumptions, okay, for binomial experiment to take place. Okay, we have some assumption. For it to be called a binomial distribution, there must be or the experiment must follow the following assumptions. Okay, let's go with the assumptions. So the underlying assumption of the binomial distribution are that there is only one outcome for each trial. Correct. That is the first assumption. We only have one outcome out of what? Outcome out of the experiment. Out of the experiment. Okay? So we have one possible outcome out of the experiment or out of the trial. Okay, stroke trial. Okay, that's the first assumption. The second assumption, each trial has the same probability of success. That's the second that is the second what? The second assumption. That is, the experiment will be like the outcomes will have 50-50. Okay, that is a half. If they are two what? Maybe for the case of what? Tossing, that is a coin. But let me not generalize that. Let me be specific, that is be more general, sorry. So the trial has the same probability, so we have same that is same probability. So each trial, okay, each trial has the same what? The same probability of success. Okay, that's the second outcome. What about the third outcome? Each trial is mutually exclusive or independent of one another. So each each trial, it is mutually exclusive. What does this mean? It means that each outcome is independent of one another. Like the outcome of the first that is experiment or the outcome of the first trial does not affect the outcome of what? Of the second trial. Like for example, if we are tossing a coin, okay, let's assume the first outcome is head, okay. So since we got ahead, it's not guaranteed that the second outcome will be what? Will be a tail, okay. So we are saying this does not affect, like one trial. You can't say you are trying to come up with a kind of distribution of what? Of like a normal distribution of what? Of tossing a coin. No. Or the tossing of coin outcomes. No. Why? Because here each outcome, it's independent of the other. Like it's hard to predict that is the second outcome, okay. It's hard. Maybe if you are accurate, then it will be an accurate guess, okay. It will be an accurate guess. But what I'm basically not to that is for me not to go out of the topic is that each outcome is independent of one another. One outcome does not affect the outcome of the second that is a trial. Good. Now let's do some more that is definitions, and also check that is some of the examples of binomial distribution. So in probability theory and statistics, the binomial, allow me to that is admit one of your colleagues. Okay, so let's continue. So in probability theory and statistics, the binomial distribution is discrete. Yes, remember I said that we have that is a uniform distribution. Uniform distribution. It is discrete. Okay. We also say that Poisson distribution. Poisson distribution. It's also discrete. Binomial distribution. Binomial distribution. It's also a discrete distribution. Okay. Also Bernoulli distribution. It's also what? It's also a discrete distribution. Okay. Then we have what we call continuous distributions. Remember we talked about uniform distribution. It's a continuous distribution, and also it's exponential distribution continuous. Yes, exponential distribution. It's also a continuous distribution. Okay. Yes. Now let's continue. So we were saying that binomial distribution is a discrete probability distribution. Why? It gives only two possible results in an experiment. Okay, it only gives us two possible outcomes. Okay, or it gives us two outcomes in an experiment, either a success or a failure. Okay, it's either we get a success or we get what? We get a failure. For example, if we toss a coin, there could be only two possible outcomes. Either we get a head or a tail. Okay, if any test is taken, then there could be only two results, either pass or a fail. That is when maybe we are doing that is the test. Okay, that is the exam test or a cut. Okay, we could only have two results, that is a pass or a fail. Okay, so this kind of distribution, all this distribution, it's also known as binomial probability distribution. Okay, so it's we have said that binomial distribution, it is that is a probability distribution. Okay, which probability distribution? The one which that is where we have likelihood of only two outcomes, that is out of what? Out of an experiment. Okay, either that is a pass, okay, or a fail. Okay, either a head or a tail, either success or failure. Okay, yes, so we only have two possible outcomes. Let me give you that is an example. Okay, that is like a good example. Let's assume maybe you are a basketballer. Okay, and you we have the basketball pitch. Okay, and then here you are, and you have the ball. Okay, so we want to make some counts. Okay, that is trials. The trials, like I'm calling counts because they are trials. Okay, so let's make trials that the ball will go through this basket. Okay, that is, the ball will go through the basket. Okay, so we can maybe make how many trials? Let's assume we have 10 trials. And then out of trials, 10 trials, we get 6, they were successful, meaning the ball went through the basket. Okay, so X in binomial distribution denotes the number of successes. So our X will be what? 6. Okay, meaning we that is, out of 10 trials, okay, only 6 trials were what? Were a success. Okay, so meaning that is, the rest were not success, were a failure. So failure, we had what? N minus what? N minus x, which is 4. Okay, so you can see we are dealing with two possible what? Outcomes in this case. Good. Let's continue with the binomial distribution examples. Okay, as we already know, binomial distribution gives the possibility of a different set of outcome. In real life, the concept is used for: number one, finding the quantity of a raw and used materials while making what? A product. While taking a survey, you can either get a positive or a negative reviews from the public. Okay, by saying yes or no in a survey, meaning you are either accepting or rejecting, we can check whether the number of persons reviews reviews the particular what? The particular channel. So it's either we say yes or no. Okay, so to find the number of male and female employees in an organization, yes, it's either a female, or that is a male, or a female. Okay, so you can see here we have two possible outcomes when that is, it comes to what? To gender. Okay, all right, then we have the number of votes collected by a candidate in an election. Okay, it's counted based on what? Based on 0 or 1 probability. Okay, all right, nice. Let's go now to the properties of binomial distribution. Okay, the properties of binomial distribution. Any question up to that point before maybe I go to the that is binomial, all the properties? Any question up to that point? Are we together? Are we together? Jesse, we are together. Belinda, we are together. Amy, we are together. Only four. Then, Naomi, Vincent, Wambua. Okay, that's already 10. So meaning we are together. I'm clear. I'm explaining well. Good. Let's now go to the properties. So the properties are like the assumptions which we made. Okay? They are like the assumptions which we made. Like, for example, there are only two possible outcomes. In binomial experiment, we only have two possible outcomes. It can be true or false. It's either success or failure. It's either yes or no. It's more of a binary outcome. Okay, for those who maybe have knowledge in what in computer, that is in computer. That is where when we are dealing with zeros and ones, binary. It's either one or zero. Okay, so there is n number of independent trials or a fixed number of times repeated trials. Like, let's assume n is the what? Like we are saying we have n numbers of trials, meaning n can be 10, n can be 5, n can be 3, okay? Depending with your what? With your that is the number of trials. That's why we are saying that we have that is n, or there is n number of independent trials. Okay, then the probability of success and failure remains the same for each trial. So like the probability of each that is outcome is the same. The probability of each outcome is the same. Like for example, if we are tossing that is a coin, that is the probability of getting a head, and the probability of getting a head is the same. Meaning the probabilities is half half. Okay. If we are dealing of with probability of that is yes, I guess so. That is, let's say, of success and failure, it's either a half or half. Okay, yes, depending with the number of what, that is the possible outcomes, because here we only have two outcomes. Okay, so meaning here, example of rolling a coin, it's not what, it's not that is a binomial, it's not a binomial experiment. Okay, rolling of a die, it's not that is a binomial experiment. Why? Because with the rolling of a dice, you can get an outcome of 1, 2, 3. Okay, you can get 4, you can get 5, you can get 6. Okay, even though the probability of getting that is of each outcome is 1/6, but we are having more than two outcomes there. Okay, yes, so the best example is rolling of a toys, sorry, not rolling, but tossing of a coin. Okay, then after that, we also have the one which I gave you of the basketball. That can be also a good example. Good. So we were here, the probability of success or failure is the same. Then the only number of success is calculated out of n independent trials. Like, remember I said the x counts the total number of what? The total number of successful outcomes. So we are saying that only the number of successes is calculated out of n independent trials. Meaning, like, if we get 6 trials, then we are good. We don't calculate that is the number of failures. Okay, rather we only calculate the number of what? The number of successful independent trials. Okay, good. We also say that every trial is an independent trial. Okay, which means the outcome of one trial does not affect the outcome of the what? Of the other trial. Good. I guess we are now good up to that point. Let's get now to understanding binomial distribution. Okay, so binomial distribution, from its formula, okay, we usually have different components in its formula. Okay, you'll come across something we call P. We'll also come across something we call what? Q. Remember, in survival analysis, okay, that is from the survival analysis. I guess some of you, if you did statistics, then you did what? Then you did that is a survival analysis. And what does survival analysis state? Like, the probability of living, okay, and plus probability of death, okay, it's equal to what? To 1. Okay, that is probability of maybe surviving for the next t years, okay, all for the next t number of years, plus probability of dying in the next t years is equals to what? Is equals to 1. Meaning, probability of living to the next maybe n years, okay, or t years, it's equal to 1 minus probability of you dying after what? After t years. Okay, yes, so basically this is the probability. Okay, yes, that is probability. It's like the probability of success plus probability of failure is equals to what? 1. Okay, if we talk about probability that is of success, then it will be 1 by minus probability of what? Of failure. That's the same what? The same ideology. Okay, yes, so here P will mean what? P will mean it's the probability of what? Of success. Okay, then Q will be probability of what? Of failure. Okay, please note that. So we've talked about P, we've talked about Q. Okay, we'll also talk about X. In fact, we've talked about X, whereby X is the number of successful trials. Okay, what else? We'll have that is a combination. Okay, we'll also have the combination part of the formula. Okay, that is n combine what? X. Okay, n combine x, and remember that n combine x is equal to if maybe we have to simplify it in mathematical way, it will be n factorial divided by n minus x factorial multiplied by x factorial. Okay, yes, So we shall also talk about factorial. Like when we are dealing with factorial, like for example, let me say it is 2 factorial. What is 2 factorial? So 2 factorial means or factorial means you are multiplying that value, okay, with what? With the values descending with one step, okay, up to 1. Like for example, it will be 2 factorial will be 2 multiplied by what? By 1. Meaning it's the value we've descended by what? By one step to 1. Okay. So what about 5 factorial? If it is 5 factorial, we'll be descending that value with by what? By 1. Okay. Then do all the what? That is the multiplication of all those values. So for 5 factorial, it will be 5 multiplied by 4, okay, multiplied by 3, multiplied by 2, multiplied by 1, okay. That is the value all the way to what? To 1, okay, with a step of 1. Then you do what? You do multiplication. So 4 factorial basically means 4 multiplied by that is 3 multiplied by 2 multiplied by what? By 1. That's what we mean by factorial. Then, once now, since I have explained all this, then I guess we are we are done with what? We are done with binomial distribution. Okay? We are done with the binomial distribution because that's the formula which we use to calculate what? The probabilities. Okay? Like we can calculate the probability of maybe a certain number of trials maybe happening or to be a success or to be what? To be a failure. All right. Now let's go to understanding binomial distribution. So binomial distribution, of course, we had discussed and said that is the most common discrete distribution used in statistics, as opposed to continuous distribution such as normal distribution. This is because binomial distribution only counts 2 states, typically represents 1 for success, 0 for what? Failure. Okay? Given number of what? Given number of trials in the data. The binomial distribution thus represents the probability of X successes in N trials, okay, given a success probability P for each trial. So binomial distribution or binomial probability, it's the probability for X successes. Maybe that is for maybe 6 successes out of 10 trials, probability of 4 successes out of 10 trials, or 2 successes out of 10 trials, 8 successes out of 10 trials. So here we are trying to check the probability that X number of successes, okay, or we will obtain 6 number of successes in our maybe N number of trials, okay, given a success probability of P for each trial. Okay, okay, good. So binomial distribution summarizes the number of trials or observations when each trial has the same probability of attaining one particular value. Binomial distribution gives us a summary of the number of trials or observations when each trial has the same what? Has the same number of probabilities. That is to attain a particular value. Okay, right. So we have the binomial distribution determines the probability of observing or specified number of successful outcomes in a specified number of what? number of trials. The binomial distribution is often used in social science statistics. It's a building block for models for dichotomous outcome variables. So this is just that is some of the applications of what binomial distribution. Okay, and it happens when we have dichotomous, meaning di meaning two, like we have two possible outcomes. Okay, so like for example, maybe when we are if like when we are having that is or when we are having the American what election, we usually hear that maybe it's either Republican or Democrats will win the upcoming what the upcoming that is the election. Okay, so here you can see we have two possible outcomes, that is either Republicans will win the election, or Democrats will what will win the election. Okay, or whether an individual will die within a specified period of time. Yes, that is when we are dealing with what? When we are dealing with when we are dealing with survival what? Survival analysis. When we are dealing with survival analysis. Good. Any question up to that point? Are we all good? Is my explanation clear? All right, good, good, good. Can see we are all together. Thank you, thank you, thank you, guys. Thank you. Right. Now let's come to analyzing what? The binomial distribution. I guess I have already explained all this. By the way, I've already explained this. I've already done this, I've already done this, I've already done this. Okay? Because remember when we were discussing about what? When we were discussing about that is the formula. Okay? That is the formula for binomial distribution. Okay? All right. Let's now come to the what? To the formula. So this is the formula of binomial distribution. Okay. That is, we are trying to check the probability, okay, of what? Of X number of trials, okay, or that is probability of X a successful number of trials, okay, given what? Given number n total number of trials, okay, and what? Same probability in each outcome. Okay, nice. Then it will be equal to n combine x. Remember, for this n combine x, I had already told you it is n, okay, factorial, divide by what? Divide by n minus x factorial, okay, multiply by x factorial. Okay, nice. Then we have multiply by, let me just use a dot or a star to show multiplication, multiply by probability of x, that is trials. So that is the probability of success that is raised to the power of the successful number of trials. Okay, then multiply by 1 minus p. What is 1 minus p? 1 minus p is q. Remember that we said q plus p is equals to what? To 1. Probability of that is failure plus probability of success should what? Should give us 1. Okay, remember that. So 1 minus p will be our what? Probability of failure. Raised to n minus what? N minus x. 1 minus p raised to n minus x. And what is n minus x? Can someone tell me what is n minus x? Someone please to tell me. You can raise your hand or you can type on the chat area. Okay, Caleb Masati, do we really have the notes? No, you don't have the notes. I will share this later. Okay, I'll share the notes later. Okay, yes, Michael, number of failures, correct, very true. So n minus x is the number of failures because we know n is the total number of trials, x is the total number of successful what? Successful trials. Okay, so multiply by n minus what? N minus x. Can we compute this maybe mathematically? Yes, let's try and compute this mathematically. Okay, nice. So we know the probability of success and probability of let me just give the example. So I'm going to work with the example of what? Of that is the basketball. Okay, so let's assume um, Amy loves maybe basketball. Okay, so and we are trying to draw this ball through the what? Through the basket what? The basket, the basket pitch. Okay. Any has 10 trials. That is n number of trials. It's what? It's 10. So any tries is best. Okay. And no, let me reduce the number of trials. Why? Because check it here. Check this. I want us to because if we are maybe we are doing n factorial, it will be a long because we'll have 10 times 9 times 8 times 7 times, yeah, that will be a lot. Okay, let me just go with 5 trials. Okay, so any as a total 5, that is a total of 5 trials to that is through the to draw the ball through the what? Through the basket. Okay, so the first trial he wins. Okay, second trials maybe he wins. Third trial he loses. Okay, fourth trial he wins. Fifth trial he does what? He loses. So in this case, what is x? What is our x? Guys, let's make it interactive. What will be our x? Maybe you can unmute and that is answer. Okay, just unmute and answer so that I may not have to go back to see who was raised. And okay, I can see you have responded on the chat area. That is 3. Yes, so we have 3. X is 3. What is our n? N is what? N is 5. Okay, and meaning now n minus x, it is what? It is 2, which is this one. So for us, we have the x, we have n minus x. Since this is a win or lose trial, then it means we have the same what? Probability. Okay, so our probability or the probability between two possible outcomes is always half. So our probability is 0. What? 0.5. So let's assume p is equals to what? 0.5. So we have 0.5 as our p. So we know 1 minus p will be what? Will be also 0.5. 1 minus p will be also 0.5 because it will be 1 minus, that is 1 minus 0.5. Okay, so we already have all that is values, all we need to do what? To do our calculations. Okay, good. Let's now do this calculation. Since that is, we have a simplified way to calculate combination, then we are going to use this combination to calculate what? To calculate the probability. Now, we are doing the probability that we have what? That is that we have three possible outcomes. So it will be probability of X happening, or the probability of us getting what? Getting three successes, okay, in our trial, okay, or the probability of us that is putting or throwing the ball that is through the what? Through the basket. So we know that is X is our 3. So it will be N. What is our N? N is 5. So we'll do N factorial. So it will be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So that is N factorial. Okay, then let's come to X factorial, or N minus X. So that will be 2 factorial, right? So it will be 2 multiplied by 1. N minus X is 2. So we have 2 factorial. So it will be 2 multiplied by what? Multiplied by X. Okay. Then multiply by 1. Then we multiply by X factorial. X factorial, we know it is 3. That is 3 factorial. So it will be 3 multiplied by 2 multiplied by 1. Okay, we might decide maybe to finish this part. So anyway, or we can still continue. So with this, it will be now multiplied by P. What is our P? Our P is the probability of success. So it will be multiplied by 0.5 raised to X, or raised to the number of what? Number of successes. Okay, then multiply by 1 minus P. 1 minus P, we've seen it's also 0.5. So it will be 0.5 raised by N minus X. We have N minus X here as 2. Okay, now let's continue with our computation. So let's just simplify. So I'm just going to divide this, that is cancel that with this. So here we are left with 5 multiplied by 4 divide by what? 2. Okay, I can as well divide this and this to have 2. So in this case we have now 10, that is the probability of X is equals to 3 will be equal to 10 multiplied by 0.5 cubed multiplied by 0.5 squared. Okay, 0.5 cubed, I guess this is 0.1225. Can someone that is confirm that? So 0.5 multiplied by 0.5 multiplied by 0.5. Yes, I was correct. So 0.25, and this one will be 0.25. Okay, so now our output will be 0.125 multiplied by 0.25 multiplied by 10. Okay, so in this case, it will be 0.125 multiplied by 2.5. Okay, which will be now the probability that x is equals to 3 will be equal to, so multiply by 2.5. So we have 0.312 as what? 25 as the probability that we will have what? We will have three successful what? Outcome. Are we together up to that point? Are we together? Okay, I can see Dennis. Since there are only two possible outcomes in binomial distribution, does it mean P and Q are always equal to 0.5? Yes, because remember under our property, that is our properties. Okay, and our properties, we said we only have two what? Two outcomes, two possible outcomes. Okay, that is a tail and what? A tail, maybe a success and a failure. Okay, and you can see here the probability of success or failure remains the same for what? For each trial. Okay, get this property. The that is the probability of success or failure remains the same for each trial. Like when you are tossing a coin, probability of getting a head is half. Probability of getting a tail is half. Okay. Yes. Another question? Are we all good? Please thumbs up. Thumbs up. I just want to see thumbs up once more. Denise, Ine, Belinda, Jesset. I just need 10. Nice. Good. Then we are good. We are good. Okay. Let's now continue. So we are done with this part. In fact, I'm done on this part. You can just go and read that. You'll just read through the notes. Okay. But whatever I've said, it's what? It's in this. Okay. It is in this. It is in this. Okay. Right. Then we shall also go to that is to the expectation, like the mean of binomial distribution. You will find that the mean of the distribution it's what? NP. Okay. The mean of the distribution it's NP. Okay. Yes, which is the expected value or the mean of binomial is calculated by multiplying the number of trials by the probability of successes, okay, which is NP. Then we have some takeaways, okay. Let me have the takeaway as the last thing, okay. Yes. So let's go with this, okay. So the binomial or the mean of the binomial distribution it's NP and the variance it's NPQ. Okay, the variance is what? NPQ. Basically NP into 1 minus what? 1 minus P, which is presented here. Okay, so that is yes, it can be this way, or it can be, you might find maybe some books saying it will be let's expand this, so it will be np minus np squared when maybe you open these brackets. Okay, yes, so that's it. Okay, that's it. So um, we've seen that the mean of that is the mean, it's np. The variance is what? It's npq. So when p is equals to 0.5, the distribution is what? Symmetric around the mean. Okay, when p it's 0.5, the distribution it's greater than 0.5, the distribution it's skewed to the left. Okay, now maybe an update. Sometimes it depends with the probabilities or with what maybe that is uh, the the conditions in your data. Okay, maybe you might be given that is a probability which is more than 0.5, maybe for successful what? Trial, meaning they have used different maybe methods to come up with what? With the probabilities. Okay, so with that you'll have to go with that probability. But let's assume maybe you are working with an experiment whereby you are totally not given any probability value. Okay, either for success or for failure. Then it means you will have to go what? You will have to go with the, that is with the half all the same probabilities. Okay, yes, take note of that. So the variance of binomial distribution, okay, like let's say we are saying when p it's equal to 0.5, then it means the distribution is symmetric around the mean. Okay, when it is greater than 0.5, then it is skewed to the left. When we have less than 0.5, then we are skewed to the what? To the right. Then the binomial, take point of this. Here now we are moving from binomial to Bernoulli. Okay, we are moving from binomial to Bernoulli. That is Bernoulli trios. Okay, yeah, I think you remember Bernoulli principle in physics class back in high school. Okay, Bernoulli's principle. Okay, so for the binomial distribution is the sum of a series of multiple independent and identically distributed Bernoulli trios. Okay, that is, it is IID, independent and identically distributed trials. Okay, so in Bernoulli trial, the experiment is said to be random and can only have one possible outcome. Okay, it can only have it can only have two. Sorry, it can only have two possible outcomes, either success or failure. But for one trial, okay, that's the difference between Bernoulli and what? Binomial. For Bernoulli, only involves one trial, meaning n is equals to what? To 1. Okay, like flipping a coin once. That's a Bernoulli distribution. If we toss the second time, okay, then that now changes from Bernoulli to binomial distribution. Okay, all right. So for instance, flipping a coin is considered to be a Bernoulli trial. Each trial can only take one of the two values, either head or a tail. Each success has the same probability. That is, the probability of flipping a head is 0.5 and probability of flipping a tail is also 0.5. and the results of one trial do not influence the result of the other. Okay, therefore Bernoulli distribution is a special case of binomial distribution where the number of trials is equals to what? 1. So where the number of trials, or when we only have one trial, okay, then that is a Bernoulli what? A Bernoulli trial or a Bernoulli distribution. Okay? Then if we have more than one trials, now it changes from Bernoulli to what? To binomial distribution. Are we clear up to that point? Thumbs up if that point has gotten on. Only Heini got that point. Jesse got. Dennis the third. Otieno fourth. Only 4 people. Okay, let me repeat that. We are saying that, like, for one trial, let's say we are flipping that is a coin once. If we flip a coin once, okay, meaning we have only made one trial, that becomes a Bernoulli, or we can say that's a Bernoulli trial. Why? Because n, whereby n is the total number of trials, n is equals to 1 for Bernoulli distribution or trial to happen. Okay, if we try to flip the coin the second time, now it changes from Bernoulli to binomial. Why? Because for Bernoulli cannot be what? Cannot like model more than what? More than one trial. Okay, so if we go to the second trial, meaning we have done 2 trials, then now it changes from Bernoulli to binomial. That's why we are saying that Bernoulli distribution is a special case of binomial distribution where the number of trials n is equals to 1. Point home. Let's go now to the takeaways, and then we will be done with the what? With binomial distribution and Bernoulli distribution. Okay, nice. Right. So we have key takeaways. The binomial distribution is a probability distribution that summarizes the likelihood that a value will take one of the two independent values under a given set of parameter or assumptions. We've already discussed that. The underlying assumption of binomial distribution are that there is only one possible outcome for each trial, that each trial has the same probability of success, and that each trial is mutually exclusive or independent of one another. The binomial distribution is common discrete distribution used in what? In statistics, opposed to continuous distribution such as uh, normal distribution. Okay, I guess that's clear. Okay, I guess that it's clear. Any question up to that point? As I'm cleaning, I want to share the notes immediately after this class as I'm sharing the recordings. Okay, it does where the probabilities P explanation of property does it. Okay, since the kindly repeat on the difference. Which difference Kennedy? Oh, I guess it's the difference between binary and binomial. Explanation of skewness that doesn't fit on the properties of binomial. Does it? No. So the things with the skewness, we can't say it is what? It's part of the properties. Why? Because not all the that is not all binary trials or experiment are skewed. Okay, that we just say that maybe you have an accurate that is a way of calculating that is the probability between what, between success or failure. Like maybe you might use Monte Carlo simulation, okay, to get the exact probabilities. Okay, if you use that, you might, in some cases, you might get greater or less than zero point 0.5. Okay, but we know that is the probability of success of each trial should be what? Should be zero point 0.5. But at some exemptions, or maybe where you are given specific or you are given the probabilities, like the probability of success, then that's where maybe you will what, yeah, you will have to use that case of skewness. Okay, but if you are not given any value, then it means what? Then it means that is then it means the probability of success or uh, the probability of success or the probability of success or failure is the same. Any or like chance, a dice, okay, will roll one with 10 attempts. The probability is 0 point, a dice. That's why I didn't want to talk about dice, because it might confuse us, because we have different outcomes of that is dice. Okay, all is in the dice that six sided that is thing. Okay, yeah, so maybe if we roll it, maybe we can get that is a dice, which is we can get a 4, we can get a 5, we can get a 6. So with that, we are not sure of what, getting what, two possible outcomes. For that, it can be have six possible outcomes. Okay, that's why I didn't want to use dice. Okay, yes. Any other question, as maybe um, I'm cleaning the data. All right. Oh, now I get your idea. That is, I get your concept, Aini. Like if the trial, if you have specified, that is, once I roll the that is the dice. Okay, I only need one specific outcome. Like I want to see a one that is the one-sided part. Okay, so if I roll the dice or yes and get a one, that's a success. If I roll the dice and get maybe any other value, any other side, either four-sided or the four-side part or the six-side part, it's a failure. Yes, maybe you can take it in that case. Okay, you can take it in that that is in that side. All right. Yes, and when you take it in that side, then now the point of skewness will what? Will apply. The point of the skewness will apply. That's okay. That's okay. That's an example of where probability is not equal to zero point 0.5. Yes, that's okay. Thank you. Thank you very much, Aini, for that. That is a additional comment. Thank you. That's awesome. All right. Any other question? Okay. If